Yeah. So today's agenda is basically we will be doing a very small analysis. Um, Pretty much like suppose you have a relational database table and somebody is asking you to do some query. So here also we will be doing some data curation. So all analysis are coming under the data curation part. So we'll be directly jumping into a program and slowly, as you have discussed, so bottom-up approach. First write the program and then understand each and every words what you have written. Okay, so and do that multiple times until you are familiar, you are comfortable writing your own program. Okay, so today basically we'll be doing the same thing. We will be writing a program. Suppose I'll share a data that is, say, a credit transaction data, credit card data. So you have to find out like each what's the total sum of transaction per customer ID. Okay, so in RDBMS, it's a very simple query. So you write say select account number, comma, say sum of amount from that table name, say credit transaction group by account number. Okay, so in SQL you write that query, but here in Spark, how you're writing this, how you're writing a code. Okay, that's the thing we'll be trying here. Okay, so this idea is basically anytime you learn a new stuff, first you write some program. So that becomes interesting, and we also start spending time. Because coding is something interesting. It's theory discussion; it will keep on going. But yeah, then that's the reason. We'll be first writing the program, and then we'll understand like what are the stuffs we have used there. Okay, what is RTD? How did you created RTD? Okay, means by reading the data, and then how did you apply the transformation step by step, all these steps. Okay, so we will be writing so first is basically write a program, to get the total transaction for customer ID. And second thing what we'll be discussing is this one, uh, type of projects we execute. And what are the different types of projects we execute using big data tech stacks, big data technologies. And third thing, maybe we'll be starting with type permits. We'll start with what is distributed computation storage. So today's agenda is this. So without further delay, let's quickly register to Databricks notebook as we have discussed. So we'll be starting using AWS. I think Ram, you didn't introduce you. You joined today, right? So
yes.
What's your background? Like how many years of experience and what's the current technologies you are working on?
I have more than 10 years of experience into IT. So I am into DevOps and architect role.
Oh, nice. DevOps and that architectural. DevOps in cloud or on-prem?
Both.
Okay, cloud-wise, which are the cloud you're comfortable with?
AWS, Oracle Cloud, Azure.
Sorry?
AWS, Oracle Cloud, as well as Azure.
Okay, I'm not sure.
Hello.
You have 10 years of experience, Oracle Cloud and Azure Cloud. In Azure
Yeah.
Cloud, have you created any scripting, like infrastructure scripting to deploy ADF and all?
Majorly, I work on AWS and Oracle Cloud. So Azure, I work mostly on infrastructure as a service part.
So you have worked on like how to deploy, say, AWS Lambda script through Terraform or
Yeah.
through, okay, those kind of stuff you have. Okay.
Yes.
And also like setting up Kubernetes clusters or normal these things called uh, Kubernetes cluster on-prem or managing a Kubernetes cluster there in AWS. Those kind of stuffs also you're familiar with?
Yes.
Okay, okay, fair enough, awesome. So majorly you have worked on AWS related services.
Yes. Mostly. Yeah.
And Oracle, like I'm hearing it like recently, like is it also equally popular than like AWS Azure or it's very new?
Oracle Cloud mostly into the SaaS applications and Oracle kind of databases. So, right, WebLogic, what Oracle offers,
Mm-hmm.
now supports only in Oracle Kubernetes engine. In no other Kubernetes engine, WebLogic cannot be deployed at the moment.
Okay,
So,
means kind of their own services are they're converting it to SaaS. Otherwise, not like general purpose. Like,
it is general purpose, but like people who mostly use Oracle kind of services, right? Like they have more than 40 enterprise products. So if any customer is using Oracle based products, then Oracle Cloud will give much benefits, right? Because in simple terms, you will get much better performance than AWS with 50% cost what you spend in AWS.
okay, okay, got it. Okay, nice. Yeah, good. Okay, so let's start. Okay, so okay, okay, fair enough. We have a lot of DevOps tools. So you are here in India or US? India, right?
And in India, yeah.
Okay, so we'll first start with Databrick setup. Feel free to interrupt me. Okay, anybody having any queries, feel free to interrupt me. Okay, even though the code what we will be writing, that's first time you will be seeing, but still if you have any doubt, just feel free to interrupt me. Okay, you don't have to wait till the end of the program to ask me questions. Feel free to interrupt me. Okay, I'll try to answer all questions before understanding the theory part of RDD and all, but yeah, I don't want to hold it until we finish the discussion. Okay, so you saw, right? Means you just search Databricks community version. Okay. Databricks community version. So it's opening community.cloud.databricks.com. Then you click sign up. Okay. So you can quickly sign up, specifying your details. Can you quickly fill out the details here?
Yeah.
Company, don't mention the right company, just any junk thing. And but it's mandatory. Here your personal Gmail ID through which you'll be logging in. Not required for now. Not required.
This field is
Company, this field is required. Yeah, we did it. Right? Git.com. Okay, so here you can see there are two options are coming. The left hand side, database platform free trial for business, and the right hand side, community edition. Okay, for students and education institution. In the left hand side, if you go through that, that's only free for 14 days. Okay, we don't go through that. Rather, we'll go through the community edition, which is free for like ever. Okay, can you click that get started? Yeah, just check your email. They must have sent you a password reset link.
okay. log into my Gmail.
Yeah. Tausif, like how you're finding it, like the course content part and all. So, so how you're finding it, and
Yeah,
because
it's yeah good. Uh, it is more like practical thing, right? So we'll get good hands-on experience.
yeah, so never hesitate to any question if you find, means if you don't think about others, what other people will find it and all. Okay,
Yeah, sure.
feel free to ask me. Okay, if it is really basic and I feel like other people don't need to hear this, we will take it offline. Otherwise, don't hesitate. You can ask anything. Okay, same thing, Ram. Sorry, Vikas also. Okay.
Yes, Siddharth, so what is this basically Databricks? These are the initial founders of Spark. That is the only thing I know. So what interface they are providing basically?
Yeah, exactly. So what is happening? No, so Databricks is called Spark as a service. Just like you here, basically, Ram is saying Oracle is starting. Oracle is having their own cloud, so they have hundreds of services, and they are providing those services, the cloud version, SaaS. Like what do you call? Like say in general, so we are using say Office, Microsoft Office 365, which is what, like earlier we were using Microsoft Office. Now their cloud version is Microsoft 365. If the price is significantly less, means every other startups are using this. So basically, every product when they go into cloud or the as a service version. So similarly, like Spark is also one of the very popular distributed computation framework. So there are a couple of initiatives which provides Spark as a service. Means you don't have to set up a huge cluster. You don't have to basically hire DevOps people and maintain DevOps team and all. And you don't want to basically build a CI/CD pipeline. You don't want to build a code version, so version, and you don't want to do anything. Just like earlier people were companies where you setting up Microsoft Exchange servers and all this stuff. You don't have to do all this infrastructure part. You only, just like you are registering to Facebook and doing and using Facebook. Similarly, it's a cloud version. You just register there over browser, your on web, and start using it. Okay, so it's basically called Spark as a service. Okay, Databricks is the Spark as a service. Similarly, AWS Glue is also Spark as a service. It's the cloud version. You don't have to worry about the cluster. You don't have to tune it. Okay, so here basically you will not find much options to tune the clusters. Okay, so everything is automatically configured. So same in AWS Glue also similar thing. They will not allow you to do any modification in the infrastructure part. They will give you a place to write the code. That's it, and you will execute there. Okay, it's a cloud version of Spark. And this Databricks team is the team behind the Spark project itself. This Matt Tijaria and his team. He was doing PhD there in MIT, and he started this project. And later it became popular, and they just moved. They just licensed it under Apache. And post that, they started their own company, Databricks. Databricks is a company. They provide it as Spark as a service, and the community version is free for everybody. Like they are providing a free OneNote cluster to practice Spark programs, and along with that, they have integrations with all these three clouds like AWS, Azure, and GCP. Okay, so the idea is basically they provides a software or basically a layer, and but in the backend they require the machines, right? Suppose you want to create a cluster of 100 node or 10 node. So for that you require machines, and clouds are all these public clouds are very good at that, right? Means in AWS, EC2 instances, Azure, virtual machines, and all this. So what they are doing, instead of starting their own cloud, which is really costly, and that's not their business actually. Their business is Spark as a service. So what they do, they provide seamless integration with all these three major clouds. started with Azure, then AWS, then recently, I think last month, they started with GCP. Okay, so you can start writing your program, creating pipelines using Databricks over any cloud. Okay, so that's the thing.
So
Okay,
Siddharth,
and yeah,
there is no need to install anything on the system, na?
yeah, you don't have to sell a system, and you don't have to install anything on your system using.
It's just like a Google Cloud. You can write a code and execute on that cloud actually only. Google
You
Cloud.
write the code there itself, execute there itself. Nothing to
Okay,
be
okay,
done in local. Okay,
okay.
but still people maintain Git and all, but Git also integration is there. Okay, all these things there.
So how does
So, Siddharth,
yeah, but
yeah, Siddharth, so how is the Databricks doing the business? Means if they are
Yeah.
providing these things for free, then
So
how they are?
this is free to basically create the awareness of their platform. So and their actual revenue comes from this. So all these clouds who are having this integration on Databricks. So suppose AWS provides what they only provide the machines. Suppose I want to run my code over a 100 node cluster using Databricks. So AWS contribution is only the EC2 machine, whichever types of machines you are using. So they bill it per hour basis. On top of that, Databricks also do some charge on that. Okay, so they also charge like per hour basis. So you have to basically so basically it's not just suppose you physically take 10 machines from AWS. Suppose they charge you say $10 per hour, but if you are using Databricks and all, the charge will be kind of $20 or $30. So that's the profit there. That's the profit they're taking out of that. And along with that, they do also and that's basically the thing. And other thing is basically Spark has a lot of connectors. So you want to pull data from say Oracle databases, or you want to pull data from say Redshift database, and these are major MPP database or RDBMS. So they create the connectors for that. Spark has the capacity to process huge data very fast, and now everything is going on Spark because of it has huge capacity to process any amount of data, any complex pipeline. So any major software provider, they should also have their own connectivity to Spark. So who will be creating that? Most of the connectors are built by Spark community only. And in the backend, they must be charging them. Suppose Oracle wants to do an integration. I'm not 100% sure, like maybe Oracle is paying them something, or suppose there is connectivity to MS SQL Server, they should also pay the amount for them to create the library. And even many public libraries like Delta Lake is also one of the Data Lake is also a service provided from them, or basically a library provided by them. And so yeah, these are the kind of things what we are using. These are the kind of things. These are the kind of things what we are what their business is all about. Mostly there are research things. They do improvise the Spark project. Means you see every 2 months, 3 months, they release the new versions. And along with that, these libraries. And in fact, they have huge, they make a lot of money out of trainings also. If you just, if you go through YouTube, say Spark Databricks. Delete content, show Databricks. So they have, in fact, there are a couple of Indians are also there who are kind of like public figure. Means they have a lot of training contents. So all this, sorry,
The potential of data and AI is big.
all these videos what we are seeing, these are basically published by Databricks. So what they do, they run different webinars. So they take multiple hours of webinars on Spark and different libraries like that, and streaming and all this. And so these courses are very costly. Like if you ask them for kind of 10 hours or like 20 hours program, they will be charging thousands of dollars. Okay, so I think there is a very good person. I'm just forgetting his name. Anybody remember? I'm forgetting his name.
Whose name? I mean,
They're in Spark.
the Prashant Pandey you were talking about.
No. He's actually from Databricks and he's providing training. I think we should find it if you just search it.
Okay.
This guy. This guy. So you can follow him also. He is also kind of he runs multiple training programs, and after like few years he just published it into YouTube. You'll find his videos like almost this is uh, just means yeah, nothing to hide. Like people learn from multiple sources. You joined here, like these are all advanced stuffs. Like once you have some basics, then maybe you will be enjoying. Like if you go through these stuffs, a lot of things are there. If you see this video, it is few hours of video. I think why it's not showing here. Your internet is slow or something like that. Yeah, it's a 6 hours video. So this guy is kind of a very good guy. Like if you right now it may be difficult for you to go through, but he is discussing about the Sparks tuning part, optimization part. Okay, so like these kind of people are there, and just make sure like you are going through Spark Summit or Databricks. These are actually genuine videos. And other videos like the people who are publishing, these are own stories, our own understanding. I am explaining Spark as per my own understanding. But yeah, these are basically authentic, like from the documentation site only. They are saying the stuff. Okay, so these are advanced stuffs. So and along with that, Databricks also provides some courses. Nothing to hide. People will generally tutors will not give all these contents, but yeah, I don't mind. Databricks courses. See, learning is a continuous process, so there's nothing to hide. Like I also keep learning from this. Since I used to purchase these courses, at least I spend some few $100 every year to get the new stuffs. What are the new libraries they're coming up with? So you can see there are self-paced courses are there. These are only affordable to me. So I go ahead with these courses. So you see there are different learning paths are there. Along with that, individual courses, I think they keep on changing the stuffs.
Yeah, Siddharth. So I have a small question. So does Databricks relates to EMR or AWS Glue?
No. They don't use either anything. They just they have their own distributions. That's the
Yes. I mean, it compares to. I mean, when you say Glue also provides Spark, does EMR provide Spark? From basically we use EMR to provision Spark environment, pass a Spark framework. Does Glue also have the same thing? AWS Glue?
yeah. So Glue and AWS EMR, they are related. So just like Databricks is a Spark as a service, similarly, AWS Glue is also a Spark as a service. But what do you think? Like why people will pay more money to more money to Databricks? There must be some additional benefit. Then only people should pay money. Otherwise, why somebody will pay? Means you can write your own code, run it on EMR cluster, or you can set up your own Hortonworks or Cloudera distribution and start executing the code. Then why I will be paying that extra money? So what additional benefit I'm getting? The additional benefit what you are getting is all these optimizations. You write the code, you do all these optimizations by your own. But if you use their distributions, they will not allow you to do the modification of the environment. You simply write the code and execute it. So there basically the thing is there. So all optimizations they have done there at their side. And the same code what you are writing and you are using say 100 node to process with say configuration 16 core and 64 GB of RAM. Pretty much same code, everything you can basically solve it in 50 or 60 node cluster, even in much faster way. So this is the level of optimizations they have incorporated there. Okay, and along with that, they have some additional tools they have created and which is only supported there in Databricks. Because these are the additional stuffs because of which people pay extra money for that. And so you can develop really fast and optimization part, most of the things are taken care inherently in the environment itself. And of course, like they have their own native libraries, which again add a lot of flexibility to your code. Because of that only, you are paying that extra money. Okay, so that distribution, just like Hortonworks, Cloudera, these are the distributions. Similarly, they have their own distributions, what they add on top of these machines, which makes your code run really faster. If you see, like if you get a chance to work on Databricks versus these other systems, you will see the difference. For sure, you'll get at least like 40%, 30% extra additional performance with lesser cost. And those cost is going to them, like they are charging the amount. So that's, even they charge more than that because it's not just performance. Along with that, they're adding a lot of additional tools also. Okay, so that is there. Okay, so these are the courses are there. You can see, so all are $200. So Databricks Certified Associate Developer, Databricks Associated ML Practitioner. You can also go through this kind of steps. Okay, so these are the additional, these are the advanced topics. Like if you feel like you are comfortable in Spark now, you want to go into the next level, then you can follow these things also. Okay, so yeah, and coming to AWS Glue and EMR, what you're saying, like EMR is basically just like it's a cloud version of same Cloudera or Hortonworks distribution where we are executing our jobs, and Glue is Spark as a service where they abstract all this infrastructure part. There in the backend also they do use EMR cluster. Okay, that's there.
Siddharth, just one thing. So we are for coding purpose for Spark we are using Databricks. What are other platforms where we can code in Spark? That is Cloudera and Horton networks you were talking about.
Yeah, so these are basically distributions. Okay, so you don't have to
Okay.
necessarily install those things to practice programs. You really don't need anything to write the program. Okay, if you can do the entire setup in local computer, even no installation required. So you can simply just open a PyCharm and you just add the libraries there and start using it. You don't have to install PyCharm. Sorry, you don't have to install Cloudera, Hortonworks, and all these things.
Okay, in case of Databricks you're talking about.
No, not even Databricks, you don't have to install anything. It's just a browser platform. No? You saw here, this is the platform writing the code. I'm saying if you're trying to write the code locally, okay, because Spark allows you to write the code in local computer and start testing those code. That is also allowed here. Okay, you can do everything. You can write the code and execute in your local computer also.
Okay, fine. So as per the industry standard, which is the platform that we are using mostly right now?
That's what no means industries. There is no such standard. Like means if a
Okay.
company is using Azure, then you will be using Azure related services like Inside Cluster or Databricks over Azure. If you are using AWS, you are using AWS EMR cluster to run your job, or AWS Glue or Databricks over AWS. All these things you are using. It depends. That company is using what.
But no one is right now using Cloudera and Horton kind of distribution network, correct?
There are still there. Some companies are still using, like who have data privacy issue and all. Like take the example of Visa or Mastercard. So they don't have government permission to move the data to public clouds and all. In fact, they make a lot of money out of their own data. They to sell their data to all data analytics companies and make tons of money out of it. For them, data is really precious. So why they'll risk moving their data from on-premise to cloud?
Okay.
Same data they can sell to hundreds of customers and make thousands and millions of dollars. So they will be definitely hesitating to move their data outside of their premise, right? So those kind of companies are still using Cloudera, Hortonworks, and all. Okay, so
Yeah, thanks.
yeah, so without further delay, I would start. Definitely, let's start the hands-on part. Otherwise, it will be boring. We'll keep on discussing this theory part forever. So this is basically the environment where we can write the code. Okay, where we can write the code and test. So this is for learning purpose. And of course, like once you are using it, the paid version, you'll also get a similar interface to write the code. Okay, but there you can create much bigger clusters and all. So in the left hand side, you can see a black ribbon. A lot of options are there. So this cluster is there. If you go there and you can create a cluster here, just simply click create cluster. Say I'm typing test, that's it, and create a cluster. It's saying 0 worker node, 0 GB RAM, 0 core, 0 DPU, 1 driver, 15 GB of RAM, 2 cores, 1 DPU, Databricks unit. So 15 GB of RAM, 2 cores is more than enough to try any kind of Spark program, isn't it? In fact, our local computer, most of the people are having 8 GB RAM or 16 GB of RAM. So which is more than sufficient to try any, like at least 5-10 GB of data you can easily process here. Okay, so this is basically the cluster what we are creating. And post that, you can see there is a workspace section. Okay, so in the workspace section, you can basically go here and click create notebook. Okay, so not test, maybe say transaction, total transaction. Total transaction, default language Python. You can use Python, Scala, SQL, R. Okay, we are using Python here. So click create. So it creates a notebook like this. In the left hand side top corner, you can see that it's detached. It's showing no cluster has been attached. So if you click again, it's appearing, and you can just attach that there, and then you can start writing the code. Once the cluster has been created, it will take a minute. Then you can start writing the code like that. Okay, so here we'll be writing the code to basically test. You can basically develop some code and test it. Okay, so feel free to ask questions. Then only you'll be comfortable. You will not hesitate going forward. It's a 60 hours program. If you'll be feeling shy from now, then you'll be shy throughout the course. Okay, I don't want to do that. So feel free to interrupt me. Okay, it's pretty much interactive sessions. So now basically what I'm doing, I'll go to my code base. Okay, so you can just search my name, Siddharth Ray, Git. It's a public repository. So all this code, I just kept it there. Accused of cheating. What is this here?
Spelling mistake.
I'm mistaken. You go here. Repositories, RDD examples. You can download this. All this code, I just kept it here. So means your internet is little slow, yours or mine's? I think you have some internet slow. Anyway, so RDD examples, data frame. This is everything which is not having a suffix py. That means it's a Scala project. Okay, so the same examples what we will be discussing in Python. The Scala version is also there. Okay, so but this RDD example is having both Scala and Python versions. Okay, so delta lake py. Similarly, streaming examples, py, dataset examples, these are Scala. Everything is there. Delta lake example, this is in Scala. Streaming examples, this is in Scala. In fact, you will find this color coding and the language, right? So all this code are there. It's publicly accessible. Okay, so that's why like it's code wise, like it's free. You can just practice any programs there. So we just downloaded the RTD part.
My directory structure is too bad.
That's fine. So what we'll be doing, everybody just create a workspace under C drive or D drive, like whichever drive you have. Right now we are manually downloading, but data frame examples onward, we will see like how to directly use Git to do the code push and pull. You don't have to manually download the code through commands only. You can do all these stuffs. Okay, so here basically in the RD examples, you can see there is a data folder is there. Okay, I'm taking a data called credit transaction. Okay, so this is the data. If you just open it in Notepad, always try to open the data in a Notepad, not in Excel. Okay, so this data is having fields like this. Okay, account number, amount, date of transaction, and category of transaction. Okay, this is tilde delimited, not comma delimited. Okay, customer ID, these are all anonymized. You can see 1, 2, 3, ABC 789. Transaction amount is $1.23. Date is 1st Jan 2015, and that person purchased some medicine there in a drugstore. Okay, similarly, this customer has spent $200 on basically 3rd of Jan 2015. Sorry, 1st of March 2015 in our electronic store. Similarly, we have multiple records are there. This particular customer 333XYJ999 has spent some $41.6967 on basically 19th Jan 2015. Means some unknown transactions, some random description is there like that. Okay, all these things are there. Okay, so this data is there. So we will be reading this data and we'll try to find out the total sum of transactions for customer ID or for account number. This person, how many transactions are appearing there? So basis that, you can see this person has multiple transactions and we want to find out the sum. Similarly, this person has done multiple transactions. This person has done multiple transactions. Like that, we have multiple customer IDs and we want to find out the total sum of transactions. Okay, pretty much like in the same SQL, what you have to write. In SQL, you can write some select account number, comma, sum of amount from trade transaction by this account number, right? This is the query. But here in Spark, how we'll be writing the code to solve the same problem. Okay, so I know like you will not be understanding, but the syntax you will not understand, but the code you will be able to understand. And feel free to ask any questions while writing the code. Okay, that's a disclaimer. I'm just making it upfront. So because we have not yet discussed what is RDD and how to create RDDs. We have discussed nothing, and we're directly jumping into the code. Okay, so that's everybody. Even like all these Databricks courses, they will see, means they will first walk you through an example, and then they will explain like what they have done and all. Okay, in that way, learning will be much faster. Otherwise, we'll be spending first 4 sessions in Python, again another 4 sessions on the definitions, what is RDD and the internal structures. Means to start the code, it will take almost 5 to 10 days. That's boring, right? So let's first directly jump into a code, and then we'll come to. Raj, you can ask me questions. Means generally this chat window, it's hidden. So most of the time, it's just not appearing anything.
So with the query now you have written, so will that be directly executing on a CSV, or it has to be loaded onto a database, right? There should some kind of transformation that it has to go through, or can you directly write a Spark on the CSV?
No, for now, I'm just writing a SQL version. We will not be writing the code in this way. We'll be writing the, I'm just saying the analysis, what you're doing. So you will be writing that same code in SQL in this way, but we are not writing SQL now. SQL is only supported in data frame. In RDD, it's pure. Okay, you have to write Python code to solve it. Okay. So,
yeah, so in that we actually import the CSV and then we have to execute the code. Cool.
Yeah. So before that, we first have to upload the data to their environment. Okay. So this is the data section, and what you can do, you can just click create table. And there is a browse option is there. Click browse and you go to your workspace.
E drive.
You just uploaded this data. After uploading the data, it will show you the path. Okay, this is the path where it has uploaded. So I'm just copying it and I'm going to the workspace. So it's showing that notebook. Okay, I'll be reading that data. Okay, I'll be saying, say, transaction RTD is equal to spark context.txt file, and I'm providing this path. Okay, so assume like it has millions of record. You won't be able to see that if you print it in the console. So I'm printing few record. It's first few records. I'm just printing in the console. I'm calling that rtt.text5 and I'm executing. Control Enter to execute the code. Okay. So first time it will take some time, and going forward it will be much faster. So you can see, so it's saying the first record is this, the exact same thing what we saw there in the notepad.
Siddharth,
Yeah, please.
so once it is uploaded, it's asking to create table with UI or create table in Notebook.
Yeah, that's basically the Databricks feature. So you can directly create Databricks tables. So we are not going into that. We are simply just what we did, no? So we'll discuss that in few minutes. So what we are trying to do, we are uploading data to the distributed file system. Okay, so you have in your warehouse, you have hundreds of TBs of data, and now you want to do some analytics on that using Spark. So you have to first pull the data from the underlying systems to your distributed file system. So what we did, we simply just pulled out the data. Okay, along with that, if you are using Databricks, Databricks gives you option to create tables on that, and you'll start writing queries and on that table, and in the backend, Databricks will process it using the attached cluster. Okay, that's that much of flexibility. But if you're writing the code from the scratch, like you are not using Databricks and all, so you have to write the code for that. You have to write the code to create a table on top of that data. It's not a very lengthy code; it's one line of code you have to write. But Databricks gives us like kind of, they have created already a UI to do that. Okay, that's the difference. Okay,
yep.
So yeah, so you just read the data and you printed say first 5 records in the console. Okay, this is how these records are appearing. Okay, now what we'll be doing. So our job is what we are looking for. We are basically trying to read the. We are basically trying to get the total sum of transaction per customer IDs. Okay, so you can see this is the customer IDs, and this is the amount part. These are the only 2 fields we are interested in, and post that we'll be applying aggregations. And the first line is basically the header. Okay, you have to discard it, because if you just include them, you won't be able to convert this amount string to this string. Okay, this header we have to discard, and then we have to do all this processing. Okay, so post that what I did, I'll be writing a little elaborate way the code, but actually after 4 or 5 sessions, we will be able to write this kind of code in 1 line. But right now I'll be writing the code in kind of 8 to 10 lines. So the reason being, so we want to basically understand in each and every step what we are doing. Okay, so each and every step what we are trying to do, all these things will be explained through this program. So but going forward, once we'll have some knowledge, we are able to write program by our own, then we'll see how to shorten this code. Okay, this kind of analysis can be done in a single line. Okay, so now basically what I want to do, I want to discard this record before doing my analysis. I know first column is account number, second one is amount, third one is date, and fourth one is category. So this operation is called filter. Okay, so transaction underscore RTD is equal, sorry, transaction, so I'm saying, say cleansed RTD is equal to transaction RTD dot filter, and inside filter I'm just passing a logic, say passing a function say called remove header. Okay, so this is all functional programming. So what you are doing, you are calling a function, and that function itself takes another function as a parameter. So def keyword, I'm writing the function say remove header, and this function takes a record of type string, and this function returns what? This function returns a list. Okay, you might be wondering why this Python syntax look this way. We'll discuss that shortly. Return record dot split, and we are splitting it through tilde, right? And now I want to see this data, this updated data, how it looks like. Syntax error, but oh. Okay, so what we can see, cleansed RTD. Okay, so you can see, but still it's okay. Remove header. What we are doing? Sorry, wait, my bad. Okay, so we want to remove the header. For remove header, what we are trying to do, we have to write a logic which will decide like whether it will return true or false for a given record. So what I'm doing, record or any substring, I will just capture from that in this. Say I just take this string in this record and I'll say not in. Okay, so this expression will resolve true or false, and basis that I'll be deciding. So what I'm saying, so I'm calling a filter transformation on my original RTD. This transaction RTD is having some 100 record, where the first line is the header and rest of the lines are actual records. And I want to get rid of the header before doing the analysis. So for that, I have to basically, that means I'm trying to remove a record from the given data set. So for that, we have a function called filter, and filter takes another function as a parameter. And this function is nothing but a predicate or a function that returns true or false. So I have to write a function in such a way that it will return true or false. How? Like if the record what you want to remove, for which it should return true, and for the record for which you don't want to remove, it should return false. So what I say in Python, you are saying this substring not in record. If I mention in, you will get to know clearly. If I'm saying this substring in record, so it's giving only one record. That means what you're saying, this record is nothing but, so filter function, what it does, it will keep on iterating through each and every record of this data. Okay, so this filter, first you created a transaction RTD, and that transaction RTD is nothing but this entire some 50 lines of data. Okay, so transaction RTD, what you just created now, transaction RTD is having all these record. Okay, transaction RTD represents all these 50 lines. Okay, and each line is nothing but a string because you read a text data, and then you call that particular RTD, that particular collection dot filter. Okay, you're calling filter function on that, and you're passing a logic. That logic will resolve into a true or false flag or a Boolean flag, saying you want to discard that record or you want to keep that record. Okay, so suppose that what I said like I want to write a logic that will return true when the value is this and false for rest of the records. So that's why you can see like it's giving only one record now. That's why it's giving only one record. But if I say not, means the reverse logic, and I'm saying this substring not in record, only keep that, rest of the records leave it. That means the first record will be removed and rest will be kept. Let me reiterate. So first what we did, we have discussed RTD is just a collection, just like you're using list, set, map, and all this. So RTD is a collection. So you are reading a huge data, which are millions of records or billions of records, and you are reading that data and creating a distributed collection. This particular RTD is not residing in a single computer's RAM during the execution time. Rather, it is residing in hundreds of computers' RAM, because it's a distributed collection. We are writing distributed program using Spark framework. So this transaction RTD is a RTD that, or a collection that represents this millions of records. And we know that millions of records is having the first line as is the header. Not necessary you'll always get the first line as the header. You may find the data where directly in the first line itself the data is there, and the data provider has communicated to you. So this data is having say 100 fields, okay, and or 20 fields, and each field or each column is like this. First column is the transaction ID, second one is the transaction timestamp, third one is the transaction type, fourth one is the amount, fifth one is the customer ID. They have given you the exact sequence of columns. Okay, you know how to interpret the data. So in that case, you don't have to remove the header because the data itself doesn't have the header. But here my data is having header. So I have to write a logic to get rid of that particular header. Okay, so here we are saying we want to remove header, maybe subsequent steps. You want to remove all these transactions where the transaction amounts are in negative. Okay, or you want to remove the transactions where the transaction amount is 0. Means anytime you may require to draw few records in a typical data pipeline, you may have to discard few records because these are junk records. Maybe we are processing some bank's transaction data or some e-commerce company's data, and the business has upfront told you that every time we just add some release or we apply some patch, we test our application, we do system testing with some predefined customers and transactions. And if you while doing the data analytics, if you see those records are appearing, you have to drop those records. Okay, so they have created some dummy users and dummy transactions. So once they release the patch or once they release a new version, they do test their systems through those data sets. Okay, and you will be always finding those records when you are doing the processing, and you have to discard those records. Okay, so that is also example of filter. Anytime you want to remove few records, that is called filter operation. Means horizontal filtering. Means horizontally you are removing few data points from the data. Okay, so that's what we are doing through filter. And as the name suggests, like filter function is used to remove records. That means the logic what you're passing inside filter, it should return true or false, isn't it? It should say whether you want to keep that record or not, or you don't want to keep the records. That's about the logic. Okay, we'll go to the Spark documentation side and we'll see these functions, but for now, just go through this. Okay, yeah, somebody saying something?
Just one thing. This not in is a keyword of Python, correct? In this RDC, how you are means how you are able to means is this notebook able to recognize REC record Python?
Yeah,
How it is able to recognize?
yeah, so I'll come to that. Say I have a string called S1 and I'm saying say hello. Okay, so I'm printing it. It's normal Python. I'm printing S, so it's printing that S. Okay, and I'm saying say hello in S.
Hello in code, na?
Oh, sorry, my bad. Okay. So we're saying like hello in S, so it's saying true. I'm saying hello one in S, it's saying false. But my one, so in is what? In is saying like whether a particular substring is existing in that string or not. Okay, that's the keyword what we are using. And suppose we are saying hello one not in S.
That is false. True.
Because hello one is not there. But I'm saying hello in S, it's saying false because hello is already there, but we are saying not in. Remember, that's basically.
No, actually, my question was how it is recognizing record. This REC it stands for record, correct? But we are not defined in your record.
Yeah, that's what. That's basically the nature of this framework. So every function what we are calling on top of this RDD, it will iterate through each and every record. So I'm saying transaction RDD dot filter, and I'm passing a function. Forget about this function. This filter function only what it does. So filter function takes a predicate that will decide whether the record will be kept or not. That means filter should and must iterate through each and every record to resolve this predicate. means to decide whether this record will be kept or not. Okay, so filter function just went through all these records and it will evaluate the function we are passing inside. Okay, and what is the data type of each record here? Each record is a string. The moment in the first line when you read that data as a transaction RDD, that RDD is a RDD of string or a collection of string. Each record is a string. And then in the filter function, you are saying whether you want to keep that record or not. Okay, the function what you are passing, that function will take each and every record, this rec record. Each record is of type string, and this function returns a true or false. That function will evaluate the logic what you are writing, and it will resolve into true or false. Getting my point? So filter function will keep on iterating through each and every record, and it will evaluate the function what you have passed inside, that is remove header, and remove header function returns true or false. So while iterating through each and every record, it will basically evaluate whether it is true or false. Okay, if it returns true, then it will be kept. If it is false, then it will be discarded. But my point, that is how this filter function works. All these transformations on RDD work in that way. It will keep on iterating through each and every record, and it will evaluate that function. Okay, initially, yeah, the right question like you are asking, like you may not be able to know like how you get to know, means I have to write a function that takes a string and returns list of string. Actually, it's not list, it's actually Boolean it should return. So I'm saying I'm writing a function remove header that should take a record and it should return Boolean value. And basically this record is of type string. Okay, you passed a string inside. Okay, so this string is nothing but all these records in this particular data, one at a time, not all at a time, rather one at a time. I'm passing one function, one record at a time, and that function will return whether true or false. Okay, so what happened? So you call transaction RDD, then dot filter, then you pass this logic. That logic will decide which record will be kept and which will be discarded. So it will basically keep on iterating through each and every record, and it will evaluate this thing. And you know, Python, everything is optional. So means this data type and everything is optional, but we are just trying to understand like in each step, what is the input and what is the output. So in this filter function, the input is for every record, the data type is string and it's returning Boolean. So that's the logic we are applying here to basically get the clean state data to after removing the header. So whatever the remaining records left, that we just got out of it. Okay, so first step, we read the data as a huge distributed collection called RTD. Then we applied a logic to get rid of the unwanted records. And then next, what we'll be doing, we will be only extracting these two fields. We are not interested in the date and the category part because we want to only find out the sum of transactions. So for that, what we are doing, we have to only keep these two records and remaining records we have to discard. Okay, this kind of transformation is called mapping. You are applying map operations. Okay, map means you are mapping each string, this whole string, into a tuple of say two fields. This is the first field and this is the second field. That means each record will be mapped from a string to tuple of two fields. So let's first maybe write the pseudocode for that, like how we are solving this problem. First, we read the data as a big collection or RDD. Then we remove the header because that's not the data point. We have to discard that. Then extract the account number and amount. Okay. Then aggregate the account number and calculate sum of transaction. Okay, so these are the 4 steps we have to go through to find out the answer what we are looking for. So first we read the data as a big collection, that is transaction RDD, what we saw. We created transaction RDD. This is a collection that holds all this data. Okay, that holds all this data. You have 50 data points. So all 50 data points are nothing but string. This transaction RDD is nothing but it's a RDD of string. Okay, it's a RDD of string. In Python, string is str. So RDD is the class from Spark itself. It's the library class from Spark itself. We'll discuss that in details. For now, just hear these words and try to write the code by yourself and speak those terms. Okay, and then we'll discuss like at least another 4 or 5 examples, and everybody will get a chance to write the code. Okay, all are different programs, but the logic is same. Okay, so first we read the data as a big collection or RDD, that is transaction RDD, and then remove the header. So you remove the header and so this is cleansed RDD, means you clean the data. And here also the data type is exactly same because you didn't apply any transformation. Okay, you didn't apply any transformation. It's same the transaction of RDD of strings. Okay, only the header is removed. Out of 50 records, first record has been discarded. You have 49 records left, and then you have to extract the account number and field. Okay, this transaction RDD has 4 fields. First one is account number, then amount, then basically date, then basically it's a description. These are the 4 fields. Now I want to extract only 2 fields. Okay, maybe basically TXN pair RDD. I want a pair of account number and amount. Okay, and here I want only 2 fields, that is account number and amount. Okay, account number and amount. These are the only 2 fields we are looking for. Okay, extract the account number and amount. Okay, transaction pair RDD, account number and amount, and then you are applying some aggregations. Okay, then you are applying some aggregations. That is, then you are applying some aggregations here, and you want to basically find out the total sum. Okay, so you are getting account num, total transaction. Okay, this is the output we are looking for. Okay, so we have written the code for first line. So we read the data and created a RDD out of it or a collection out of it, and then we write a logic to remove the header. Okay, so always just remember every time you are, so this how you write, you just created transaction RDD is equal to spark context dot text file, and here you provided the path, right? Here you provided the path to read that data, right? The second step is basically you are trying to remove the header. So for that, we have a function called filter. Okay, transaction RDD dot filter. Okay, here you saw you had kind of 50 records, not kind of, actually there are 50 records, and you're applying a filter here. You're saying filter. Inside this filter, you're passing a predicate. Okay, so predicate means a function which returns true or false. Just a term. Okay, it doesn't have any it's a syntactical significance. You are writing a function. That function will resolve into true or false. Okay, in the second step, you're basically calling a function that will remove the header, and you should get only 49 records. You should get only 49 records out of this 50. Okay, so you should get 49 records. So you're saying transaction RDD.filter, and you're saying you're passing a function, and that function should resolve into a logic, and that logic should be returning true or false. That means, let's write the logic. Say we are writing def remove header. This is the syntax to write a function. So I would say like everybody just start exploring Python, just basic thing. Okay, what we discussed, like how to define a function, def keyword, then any user defined name, say remove header, and then it takes a parameter, say record. Okay, in Python, declaring the data type is completely optional. We never mention the data type. And here you are saying return I have to write a logic that should return whether true or false. Okay. Okay. So the function what we are trying to write, that should always return true or false. That should always return true or false. Okay. We have to write a function. That function will return either true or it should return either true or false. Okay. So I'm mentioning this function remove header and it return true or false. So what's the logic I'll be returning? What's the logic I'll be writing so that it will return true or false? Let me do one thing. Let me take few sample records from here and let's discuss like how this function is working. I'm taking some few records here and I'm writing it here. Okay. And like that we have total 50 records are there. So how I'll be writing a logic that will return true or false on different records. So the logic what we have written, we have said record. So what we have written this by saying this entire string is not in record. This is the logic we have written. Okay. So let's see if I'm evaluating this expression account number tilde amount tilde date tilde category against the first record. So what it will return? It will true or false. We are saying this not in record.
True.
Right? True or false? False, right? We're saying not in.
False.
It will return false.
False.
Right? We are saying this particular string not in record. It's false because it's actually in. If I mention account number, this particular account number, amount, date, tilde in record, then it will be true, or else it will be false. If I say in is a clause that will check this particular substring in this particular string. Okay, this will check this entire substring inside this string. Okay, if it is there, then in will return true. If I say in, then only it will return true. But I want the reverse thing. I want to keep the rest of the records except this. So that means I have to write a logic which should return false for this particular record, first record only, but true for the rest of the records. So for that, I'll be saying no, not in. Sorry, not in, rather the negation of that, not in record. These are all keywords in Python. I'm saying this substring not in record. So it will resolve false here. It will resolve true here. It will resolve true here. It will resolve true here, like that. Okay, in this way, means for the rest of the records, all it will return true except the first record. Okay, except the first record. For rest of the all records, it will return true. Got it? So remove header is the function. So that's a predicate. It will return whether true or false. Base is the logic what you are writing inside. So line number 11 is the logic you have written. So it returns true for all these records except the first record. Okay, that's why you will be discarding the first record and you will end up getting only the last 49 records. Okay, that's basically the remove header part, what you have just seen now. Okay, that what just you have just seen it now here. Okay, that part we have just done. Then the next step is basically we want to extract only these two fields, not all. So some people might be thinking, yeah, this is again another filter. Anybody having that hunch, like you feel like it's again another filter function? Vikas, what do you think? It's another filter function or it should be something different?
Something different, I guess.
Maybe another filter. Maybe another filter. Maybe.
No, filter is basically what it does. No, it's a horizontal filtering. It will decide whether it will keep this, or this. Whether it want to discard this record or this record level decide it will do. but it never says like in a given record you want to only keep this half part or you want to keep only half part. That's not about filter. This is vertical filter.
Map. We'll use map over here.
Exactly. This is called projection. You have multiple fields. You have 4 fields, but you are selecting only 2 fields. This is called projection or select clause in normal SQL. Okay. So in SQL, where clause is used for filtering. So what we just did it now, you're using filter function. But when you want to remove or you want to select a handful or a handful of columns, there basically we call it as a projection. Okay, you are projecting only a handful of columns or 2 columns out of 4 columns. Okay, this is called map function. Okay, this is called map function. Map stands for mapping. Okay, third is really extracting the account number and amount. Okay, so you are extracting. Map means, map is a function, if you have heard about in mathematics, f of x, say what you call map function came from mathematics only. Means map, this keyword is entirely from mathematics only. So if you have heard about y equal to, in linear algebra, you have heard f y equal to f of x. You can just ignore this discussion, means this few seconds, but it's worth understanding. F of x, say you say x square plus 3x plus 5. So what we say, f of x is a function which maps x to y. You put x equal to 1, you will get y equal to how much? X square is 1 plus 3 4 plus 5 9. Then you pass x equal to 2, you put x equal to 2, and you will get y equal to how much? 2 to the 4, 3 to the
15.
16.
15.
Like that, you keep on adding different values and different x, and you get different y's. So what we call in mathematics, we say f of x is a function that maps x to y. Okay, means if x equal to 1, f of x will map x to y, that is 9. If x equal to 2, you will map x equal to 2, f of x is the function that will map 2 to 15. Okay, exactly similar analogy we are saying. Here, each record is this. And you want to map it to a tuple. It's actually a string. Okay, actually in the backend, these are all strings, and you want to map this string to a tuple of 2 fields, that is 1 2 3 hyphen abc hyphen 789 comma, and the amount is 1.23. You want to map this record to this. Similarly, if you go to the second record is this. Okay, and you want to map it to a tuple. Okay, tuple is a additional data type here in Python that is used to basically create a collection of values. So here each record is a string, and I want to convert that string to a tuple of string comma float. Okay, string is the account number and value is the float is the actual transaction amount. Okay, that's how basically I want to apply the transformation. Getting my point? So that's basically what I want to do. This is called map transformation. In SQL, we call it as projection or select clause. You say select employee ID, department ID, salary from employee. Your employee table is having 20 columns, but you are only interested in these 3 columns for your analysis. So you say select employee ID, department ID, salary from that table. Okay, that's how basically you write the code. So that is called projection. You are using select clause for the projection. So that's what you're doing. That's nothing but this map function. So in Python, how you'll be resolving this? So this particular thing is basically a string. So if I say a string dot split, okay, split is a function there in Python that is used to split the records. Okay, so split the records through a delimiter. So you can see our fields are delimited through this tilde. Our fields are delimited through tilde. So what I did, I just splitted them. People from who have not done programming from quite a long time, you might be finding it difficult, but just bear with me. Okay, it's the initial level of coding we are doing. We'll be repeating the similar logic for at least another 2-3 sessions. By that time, you'll be already comfortable. Okay, just type the program. Don't copy paste it from other people. Just follow this recording and write the code by yourself. Okay, you have enough time. You have decided to learn big data for your career transition, and of course, it's with a cost, right? You have to spend some time and effort. Okay, people are making 120%, 200%, maximum 200%. One person just got a hike. So you will be getting here in India, like transition from normal software engineering or ETL to big data is minimum 50% and maximum I've seen 200%. So that means if you're getting a lot of money, means you have to put some effort, right? And it's one-time effort. Like you put an effort and you will just redeem this effort for another few years to make a lot of money. Okay, so you can just think like you are doing a favor to yourself only. You're putting some effort for your own benefit. You have an X package and you want to jump to 2X package, so you have to put some effort. Okay, so anytime I also feel like difficult something, I just visualize the next thing, like what it will result into. It will result into few lakhs extra package in my account. That's why I'm learning it. Okay, many people. Okay, I've seen, like, if you just go through the alumni group, there are almost 200 people are there. Almost 150 people are already into big data. They have all offers. Okay, so you can check with them. Like almost everybody switched, like not with minimum 70% of I. Okay, because big data means like in Spark and all these things, this is really a hot technology these days. Not in just India, in US also. You can definitely, means in US it is easy to crack a job because there are a lot of openings and there are very less genuine people are there. So cracking interview is really easy. And here in India, like Java developer is making kind of 12 lakhs or 15 lakhs with 6 years of experience. And just now, last week only, Somen just got an offer from Morgan Stanley with 120% hike. His package was kind of 7 lakhs, and he went to his earlier package was kind of 8 lakhs, and he jumped to near to like 18 or 19. And yeah, some people like Bala was a guy, like he got 200% hike. He was having 6 years of experience into Java or something, but package was only 4 lakhs, and he moved to 15 lakhs directly. 4 or 5 lakhs something, he jumped to 15 lakhs. There are a lot of opportunity. If you really want to go for a significant push in your package, just spend some time. It's 2 months. Spend some time. Okay, all work from home and all. You must be having a lot of free time. Spend some time and learn it. Okay, once you get into that, then you will see lot of money. Okay, lot of money here in big data. So trust me, I myself has made, like, this is my 4th company. Every time I make a switch, it's 100% time. So it's a lot of money. So just have patience and learn. Okay, I am here to like help you if you have any confusion. But you just search. Even you don't have to follow me. Like you can just search then in LinkedIn and all. Just put a resume, copy my resume from my LinkedIn profile, and just change the name there in the profile and publish it, and just talk to few interviewers, and just like when they're asking about the package, say 2x and see their response. 90% chances they will be agreeing. Okay, so it's a win-win for both. Okay, so you'll be also learning, and yeah, so yeah, it's basically you are doing it for yourself. Okay, so that's why you have to put some effort. Okay, so only people, like there are 2-3 people here in this batch who said like you only did the programming at the college and you forgot it now. So I'm telling this for you people. Just don't feel like, and coming to testing. Testing is like 3 people are into product based companies in the same group because I've added you yesterday. One guy, I'm forgetting his name, Sudeep, you can just ping Sudeep there and you can just have a word with him. Okay, he was into pure manual testing. He was
Okay. Okay.
and all, and he got into United Health Group. Okay, so United Health Group and a
That,
couple of other offers also he was having.
mhm.
He was a recent. I forgot other people. Only the last couple of months only I remember. So you can just have a, or you can just simply ping like people who just moved from testing to the data.
Sure, Siddharth. Yeah. Mhm.
So these are there. Okay, so just put some effort and have some patience. Don't get disheartened. Yeah, there's a lot of programming. I don't want to do it. I'm happy with my current. Don't do that. Okay. So if you have really decided, spend some more time and just evaluate. Life is all about experimentations and all. There's no harm in that, right? So yeah, coming to the example, what we are doing. So you saw like we discussed like what is mapping. So a map is nothing but this keyword came from the mathematics only. You are mapping uh, value from one format to another format. Here you saw you are mapping x to y. Similarly, here you are mapping a string record, okay, which is a delimited string record to a tuple of string comma and float. Okay, this is also mapping. You are mapping from one format to another format. Okay, you're mapping a string to a tuple of string comma float. Okay, so that means what the logic you're writing. We're writing the logic in this way. This particular string dot split. Okay, if you split, it gives, so split is returning a list. Okay, split will give you a list of all these fields. Okay, if you split it through tilde, it will give you a list of all these fields. Okay, split function does this. Okay, so this above expression, what you have written, this string dot split tilde, it gives this. You can just evaluate it quickly.
Yeah, one question.
Yeah, please.
Yeah, the split function is that the split function returns a list, or you have to use something else over that? Like dot split is not recognized as RDD, I think. Like do RDD use split? Like RDD dot split.
This is not
If
a function in RDD, it's a normal
yeah,
string function. So this should go inside the inner function. We'll see that shortly. So you can
okay.
see split function, what it does. This is a Python string only. You have kept something inside double quote. It's a string dot split tilde. You can see it's returning a list of all these fields. Okay, so suppose that what you are saying. So you split it, but you don't want that, right? But you want this. You want a tuple of this thing. Suppose that. So from this, suppose you assign it to a variable, say x equal to this. Then you're saying return a tuple. Tuple is nothing but this parenthesis. You say x of 0 means the first field, comma, x of 1, the second field. But the second field is a string, but you don't want string, right? You want a float. You have to convert it to, float. That's what you're trying to do. So let's try that code and see how it does. I just copied it. Here then it's not a function. So I'm say y equal to this. And then printing, or simply just type y. It will show you the output. So you can see it's giving a tuple of string comma decimal value this. So string you are able to recognize because it is quoted inside single quote. And this is appearing without quote means it's a number. Okay, this is the logic we are trying. You are first splitting it through tilde, and then you are extracting the 0th index and 1 index, and the 1 index you are converting it to float. Okay, so that's the thing we are doing. Let's quickly write that code. So now I want to get a, say, account amount RTD is equal to, so I have this RTD called cleanst RTD. I copy it and I'm calling a map function here. Map stands for your projection. Okay, and I'll be writing a function, say get account amount This is all user defined name we are giving. So let's write the function set def get account amount, and it should take a record. And what should it return? So what is the data type of record here? Record is of type string. So data type declaration is completely optional here, but for our own understanding, we are just writing it here. And it should return a tuple of str comma float. So what we are writing, say we are writing say splitted record is a variable, splitted record is a variable is equal to record dot split, and I'm splitting it through tilde, right? I'm splitting it through tilde, and then I'm saying return splitted record of 0 I'm creating a tuple, then float of splitted record of 1. Okay, so that's what we did, and post that we are writing this. We are trying to see the syntax error. What did we get mistake here?
String of splitted record or only splitted record of 0?
Which line?
Yeah, return splitted record of 0.
Okay, I think it's typo. Splitted record equal to record.
You just miss a parenthesis in the return section.
No, parenthesis is there. So,
No, the float after float, yeah.
okay. Very nice. So we got the output, right? That's what we are looking for. We are looking for the records, that is each record is a tuple. First one is the account number, and second one is again second one is basically the transaction amount, like that. For all records are mapped from string to tuple of string comma float, right? Tuple of string comma float. Okay, and we are only getting the first 5 records. If we are not listing all records. Okay, this is the third step. First step, we read the data as a huge distributed collection called RTD. Then we applied a transformation to get rid of the header, right? We applied the filter function to get rid of the header. Then we applied a functions to transform the record from a string format to a tuple of string comma float. Float is nothing but the transaction amount. String is nothing but the account number.
Siddharth,
Yeah, please.
why is returning each element as a tuple? Just because we return in a parenthesis, that's why?
No. Yeah. Parenthesis is nothing but tuple. Okay, just like you are using.
Yeah, I know, but I'm just asking why each element is showing in the tuple in a list.
Because you have the parent. This RDD is basically what? This RDD is a distributed collection. When you call take function take the first 5 record and convert that to a list. This RDD, if you just execute this in the next line, I'm just executing this and typing this account amount RTD. So what it is saying, it's a Python RTD. Okay, it's a RTD. Its data type is RTD. The moment you call RTD.take, it will take the first 5 records of this RTD and it will give you a list. That's why you are seeing this parenthesis. Sorry, this square bracket. So it just extracted the 5 records, 5 tuples, and it returned
Okay.
It returned the first 5 records as a list. Okay. So I wish everybody just go through this recording again and again, just come up with good questions. Okay, just like initial 10 sessions, if you are able to self type the programs, if you are able to come up with good questions, and you type multiple programs by yourself, you'll be really comfortable. Data frames are not really easy. Here you are writing 110 lines code, there it's just a single expression. It will be much easier.
One question.
Yeah, please.
The first segment, that is 1, 2, 3, that's a string. So if, with quotes, so if I want to chop out the quotes and return as it is the sentence, like 1, 2, 3, ABC 7, 8, 9, then what is the data type that we'll be going to use over there? Like I see return splitted record is not into any type, like the other one is the float type, but this one is a string type, I'm assuming.
If this is a string only.
Yeah, so if I want to chop out the quotes and return the raw data, then what is the function that I'm going to
This
pass
quote
it?
is not there. Actually, this quote is not there. You are printing it,
Okay.
that's why quote is appearing.
Okay, because of the string, because it is a string, that's why that it's quotes.
Exactly, means, but here you see, the data what you just read from the file, it doesn't have any quote, but still we are printing it in the console, it's appearing with quote, because that's how Python prints the output. But you don't have to worry when you are processing. You have to assume like there is no code. Basis that you have to write the logic. Getting my point? Only it's the
Okay,
printing
yeah.
format of Python. Python prints the strings in quoted format.
Yeah, so we took the entire record in the form of a string, and then that get amount function took the whole record as a form of a string.
Exactly. In fact, you saw that in the first line itself. In the first line, what you have written. In the first line, in the very first line, what you did, you just mentioned transaction dd dot text file, and you executed this. So what it was printing? It was also printing the output in a quoted format, right?
Yeah.
The record was printing in the quoted format. Does that mean this single quotes are there in the data? No, it's not there in the data. But still, while printing it, it prints it in this way, because Python prints the strings in quoted format, so that you will get to know, yeah, this is a string.
Okay.
Only thing. Okay, like that. So now, yeah, please.
Yeah, in the last line, it's take a 5, right? We got the first 5 as a result. So if you want only 2, 3, 4, not the first one and the last one, so what should be written instead of 5?
Sorry, come again.
No, the output is for the 5, we got 5 results, right?
Right.
So what the string and float. So if we don't want the 5 outputs and we want only 2, 3, 4 instead of first one and the last one, we don't want in the output, and what should be written instead of 5?
See, I got it. That's in Python, that is called slicing. You can basically slice the results, but that is not supported in RDD. For example, I got your point. So what we are saying, suppose I have a list having, say, 1, 2, 4, okay, and you say L of say 2 colon. So what it prints, what it gives? It gives 3. If you say 3, 2, 3, what it returns?
1, 4.
Only 3. If you mention 1, 3, what it returns? 2, 3. Like that, you can. This is called slicing. But unfortunately, RTD is not a list. It's a completely different data abstraction. Okay. But of course, yeah, you call take 5. Now it's a list. There you can use slicing. Okay, but it will not actually extract those values from the RTD. RTD will be converted to a list of 5 element, 5 strings, 5 records, and then of course you can use, say, I want say third and fourth record. So third means 1, 2, 2 colon 4. If you do this, then you can get these records. But yeah, take function doesn't have such option. Like it will not give you. So it's giving 2 and 3 records. Like 4 is exclusive, 2 is inclusive. So record index 2 and 3 just appear. But this is not actually adding any performance benefit, but it will always give you it will anyway get the first 5 records. And after that, it will do whatever the slicing you're doing.
Okay.
So that's what. So we have to finish this program, otherwise it will be half. So then what's the next step? Next step is basically, next step is, yeah, so the third step we just completed. Third step is basically this: extract the account number, amount, and all this. And then the last step is basically to aggregate. Okay, last step is basically to aggregate. So what we'll be doing, we'll be applying a function, say, we'll be applying a function called reduce by key. Okay, reduce by key. As so, the reason why we just kept it as a tuple of these fields is basically we will be, so every time we are creating a tuple of two fields, the first becomes the key and second becomes the value. And I'm saying reduce by key and I'm passing a function say sum here. Okay, and sum function is nothing but it's the, I'm saying the def keyword sum, and here I'm passing say n1 comma n2, and I'm returning n1 plus n2. Okay, so it will basically convert each. So here basically you had these records, right? So you had these records. So yeah, assume like this records is appearing twice. Okay, so this is first time it is this, and second time is 2.23, and you have another record like this. Means you have 49 records. I'm just giving. I'm saying like say we have only 4 records, and how this reduce by key function works. Let's see. So we are saying reduce by key function. So by key means it will take all records sharing the common key, and it will apply the sum operations. Okay, so here you see like the key is 1, 2, 3, ABC, 7, 8, 9, and it will sum it up. Okay, 1.23 plus 1, 2.23, that is 3.46. Okay, like that. Similarly, here 456 DA 456. So the output will be like this. Output will be again a key value pair. Okay, so for this pair it is this, and for this pair you will do this. So it will be 200 plus 210, that is 410. Okay, like that, this will keep on calculating the aggregations. Okay, let's write the code. Say total transaction RGD is equal to account amount RGD dot reduce by key, and inside that we are passing the function say sum. Okay, and we are defining the function say def sum, and sum function it's aggregate, it's a binary operation. So you have to pass the amount 1 colon float, right, and amount 2 colon float, and this function as a full return float, right, and the return amount 1 plus amount 2. Okay, so now we can basically see the output. Okay, you can see account number 333XYZ999 has made total 1249 transaction. This guy just made 871 transaction. This guy made 5081 transaction, like that. There are total 4 customer IDs. See, you can have given 5, but it's giving 4. That means there are only 4 records now in the output. So you're getting 4 records. This customer ID along with the total transaction amount is. Okay, so this is the first program. If you are able to successfully type the program by your own, so you'll really get a lot of markets.
So that's what does reduce by key how does it works?
As the
Can you
name
just explain one?
as the name suggests, so what it will do. So let's take our example, this example. Let's take this example and discuss how it happens. As the name suggests, reduce by key. It will reduce the data set. Okay, all this Spark, Hadoop, Flink, These are all map reduce frameworks. Map and reduce. Map means keep on applying different projections. Okay, projections are not straightforward like attribute to attribute. You can keep on changing the format also, just like you saw. We changed a string to tuple of string comma float. We changed a string to float, like all these kind of transformations we added. Okay, so transformations, map and reduce. Reduce means reduce the data set, apply some aggregations, right? So here let's see like how reduce function work. How reduce function work. It will keep on scanning through each and every record. Okay, so every function, just like we discussed about the float and all, sorry, the filter function and all function, filter, map, everything will keep on, these are all iterative functions. It will keep on iterating. Map function, filter function iterate one record at a time, but here it will iterate two records at a time. So it will take the first two records, okay, and it will iterate because user reduce by key function takes two parameters n1 and n2. So here you see this two records sharing the same common key. So after the iteration of the first iteration, the output will be 1, 2, 3, ABC 7, 8, 9, 1, 2, 3. Then it will go to the next record and it will again take two records. What are the two records? The previous result and the current record. Previous result is this one, 1, 2, 3, ABC 7, 8, 9, and the current record is this, right? These are the two records it will pick up and it will apply the aggregations. Okay, so now what will happen? The output will be this record what we got earlier and a new record, that is this record. Because here the key is different, so it will not be able to apply any aggregation here, isn't it? So here it's a new key altogether. So the output becomes like this. Then it will iterate to the next record, right? It will iterate to the next record. What's the next record? The previous result and the current record. So what it will result into? It will result into this.
Okay. Got it.
In this way, it will keep on iterating through the data points 1 and 2 at a time. First time, first two records, third time, the result and the third, fourth time, the result and the fourth, fifth time, the result and the fifth. Like that, it will keep on iterating.
So Siddharth, we can assume that the return value is in the form of a list of a key value pair, like a list of a tuple.
Correct. That's why every aggregation function you will see it ends with by.
By. That's right.
By key, reduce by key, group by key, aggregate by key. So those kind of things.
Okay.
We'll discuss in more details. Okay. So right now I'm also not expecting everybody should understand this because that's not the intention. Only the intention is basically keep you engaged. So you have one code and I'll give you some other data set to try by your own. So that's the only intention. But we didn't discuss about the definition of RDD, what is RDD, how to create RDD. So those things will start in the next session. Okay, so next session, what we'll be doing. So there are a couple of theory things pending now. So next session, what we'll be discussing. What is that text? Yeah. So the first part only we are able to cover today. So the rest of the two parts still pending. So next session, what we'll be doing, we will do in this way. We'll discuss the type of projects we execute. We'll jump to the theory part. We'll not jump into program. So I'll give you some assignment. We'll discuss that. Post that, we'll discuss what are the different type of projects we execute. It will take 10-20 minutes or half an hour. And then what is distributed computation and storage, that will take half an hour. And then we'll discuss about actual content. What is RTD? Then how to create RTD. And third is how to apply transformations. So the objective of question point 3 is basically to explain the program what we have written. So what is RDD we'll discuss, and then how to create RDD. So what is RDD is really theoretical part, and how to create RDD basically by calling spark context.txt file, what we have used it here. We'll discuss what is this SC. SC stands for spark context. Why didn't you create this variable, but it's automatically available to this notebook? What is this text file function? Is it the only functions to create RDD, or there are a couple of other functions are also there? Okay, so here also every step you are seeing, you are creating another RDD. Here you read a file and create an RDD. Here you applied a transformation and create an RDD. Here also you applied again another transformations to create an RDD. Like that you are doing, right? So here also you created again another RDD by applying the transformations, right? Like that you are doing. This is how to create RDD. How to apply transformations. Filter is a transformation. Map is a transformation. Reduce by key is a transformation. All these transformations are also will be discussing. All these transformations are higher order functions here. Higher order function means a function take another function as a parameter. That is called higher order function. All these things we'll be discussing in detail. Means we'll be trying to connect the dots. What we write, what program we wrote today, and after discussing the definitions of RDD, we'll be doing the we'll basically build our understanding how the definition of RDD and the concepts are related with this program. Getting my point? So that's the whole idea. Any question? And now,
Siddharth?
yeah, please.
Yeah, so like you have written here sc dot text file. So like it's a part of some module, or like if we are going to write this same code on our Python interpreter, so we need to import some module, or like it will be executing simply like this.
Exactly, you have to import something. This code, suppose you are not using Databricks, you are writing a Python code. You are creating, say, this, and you are saving it as, say, test.py. So here what you have to do, you have to import from PySpark.sql, import Spark session. And then you have to create a Spark session object. So Spark is equal to session dot builder install dot getter. We'll be creating Spark session object. Then Spark context object is a attribute there. Sc equal to Spark dot Spark context. Okay. Then you can start writing the code. This additional 3 lines of code you have to write. The rest of the code will remain as it is. Like that.
Okay.
Siddharth?
Yeah, please. Yeah.
Yeah, so just trying to ask so we'll get a tuple, right? So currently the tuple has two values. One is the string, one is float. But suppose there are more than two. Suppose there are more than like one key.
Right, that happens.
Then
so just doesn't matter how many elements are there. Just you make sure. Suppose you have 10 fields, and your key is a column 1, column 2. Value is column 3, column 4, column 5, like that. Okay, your key can be a composite key and value can be a composite value, or key can be a single value, value can be a composite value. It can be any combination. Getting a point. Every time you're applying the aggregation, the value part will be taken into aggregation part, and key part will remain as the grouping column.
So can you give an example? Like suppose there are two keys and like
Correct,
two
suppose
different
you have
floats.
I got it. So customer ID C1, year say 2021, amount say 100. Okay, say customer ID C1, year say 2021, amount say 200. Customer ID C2, amount say year say 2021, say 100. Like that, the data is there, and you convert it into a pair RDD where key is customer ID, you want to apply some aggregation. You want to find out the total sum of transactions for customer ID per year. Getting my point? For customer ID per year. Customer ID C1,
Okay.
2021, and value is 100. Okay, so after summing up, you will get say 300. Getting my point? So when the analysis is done in that way, like per customer ID per month, per customer ID per quarter, per customer ID per year, those kind of things. Okay, so this is the total transaction amount. Maybe suppose you have another column, say profit margin. Okay, if you are making 100 rupees transaction, you are getting 1 rupees profit, and you are getting, if it is 200, so the logic is different. If a person is doing less than equal to 100 transaction, so the profit margin is 1%. If a person is doing more than 100, if a person is doing 100 to 200%, 100 to 200 rupees dollar transaction, the profit margin is 0.5%. So that means here it is also $1. Here it's also $1. So this logic varies. So similarly, you can write the logic in such a way that your values are also composite values, not just transaction amount. Along with that, profit margin is also there. Okay, profit margin is $2. Like that. All these combinations are possible.
Okay, got it.
Any other questions, Adim, Asutosh?
Not from my side today. I will just review it again.
Yeah. Sure. Just go through the recording and try to self-type the program. So this piece, actually Ram will share it over WhatsApp. Okay, only this part. Okay, program part, I'd request everybody try by your own. Just follow this recording and type the program by your own. If you still struggle, then ping in the group, so Ram will respond to you with the program. Okay, but
okay. Okay, sure. Yeah.
Yeah. So Raj, any other question? Raj,
Siddharth, do we have any other sample data other than these 50 records?
Yeah. So yeah, I forgot about the assignment part. So you can do the same program on this data set also. There is a finance data is there.
Okay.
So in this finance data, this is salary data of different students. So find out the not this one, maybe. So what we can do, so maybe this data, what you can see, this transaction sync data you can, or transaction fact data you see. Transaction fact data is there. So in the transaction fact, you can see this amount is there, and customer ID is there. Okay, you can find out the sum of transaction for customer ID. Okay, you can take it out. There it was delta, here it is pipe as the delimiter. Okay.
Okay.
Okay, try this program. Yeah. Adim, Tausif, any question?
Not for now.
Hello?
But I would say like, yeah, somebody say, because you're something or somebody. Okay, so just just spend some time. Okay, definitely any. Yeah, please Tausif.
Yeah, I feel the program, I understood it. I'll try to do the assignment today.
Yeah, sure, definitely. So yeah, means anything what you learn, the initial part is really crucial. Like if you spend some time, you build your comfortability on that, then rest of the part will be easy. Okay, if you initially give up, means give up. That's why I prefer not one free demo sessions. At least 4-5 sessions should be there, so that at least a person can assess himself. Like we are all interested. That's why only we are spending time on weekends. So I respect everybody's time. But the only thing is basically you have to also assess yourself, right? Means you have enough time and you have enough background to basically try all these programs. Then only you make a call whether you really want to opt for this course or not, isn't it? That's why it's really difficult. Like one demo sessions, you have to make a call in one day. You pay a lot of money, and then you find like it's not useful. You're not able to understand the programs, write the program by your own. That's the whole reason I prefer like 4 sessions, at least 4 sessions, so that you have enough time to make a call, right? So with that, we'll again connect on Wednesday. So I'll share the recording in half an hour. So you can start going through that and try that program.
Did you say Wednesday IST?
Yeah, Wednesday, same time IST.
Wednesday IST. So that'll be like a Tuesday.
Tuesday night for you.
Yeah. Can you do Thursday?
Thursday, actually, there is another batch is there. It's going on at the same time. So every time there are two batches going in parallel. So that's why like weekdays either Wednesday or Thursday. But yeah, that batch will be over in another 1 or 2 weeks. Suppose that we can swap it to Thursday if everybody if you're fine out with it.
Okay.
Okay, so okay, thanks everybody. Thanks for your time. Really appreciate this.
Yeah, thank you, Siddharth.
Yeah, we'll let him connect.
Thank you, Siddharth. Bye.
Thanks.
Thank you.